Hey everybody, today we're going to solve the maze problem on LeetCode. So the problem description, there's a ball in a maze which has empty spaces and walls. The ball can go through empty spaces by rolling up, down, left, right, but it won't stop until it hits a wall. When the ball stops, it can choose the next direction. So the whole thing about this problem right here is kind of this line, but it won't stop until hitting a wall. Given the ball's start position, the destination, and the maze, determine whether the ball could stop at the destination. The maze is represented by a 2D array. 1 is a wall, 0 is an empty space. Start and destination coordinates are represented by row and column indices. So, let's see an example that they give us here. So here's what a maze looks like. 0s are open spaces, 1 is a wall. So if we start at 0, 4 right here, and we want to get to 4, 3, they give us a picture of what that looks like right here. Okay? So in this case, we can roll to the left, roll down, roll to the left, roll down, roll to the right, down, and then right, and the ball will stop at the destination. And here it's false, exact same setup, except with the destination right here, there's no way for the ball to stop right here. Okay, so we can solve this problem using depth first search, and the only trick to this problem is in a usual depth first search, we might do something where we're searching a maze where, we go up 1, or down 1, and then right and left 1. In this case, we have to figure out where the ball will stop. And it stops when it hits a wall, or it makes it to the end of the maze, okay? So before going into the code that solves it, there's some helper functions that are set up. This is a really good idea, particularly if you're solving these things in an interview. Just use a helper function, and a lot of times they're so trivial that they won't care, and you can just sort of wave your hand and say that it does something. So here's out of bounds, checks if the row or column that we're at is out of bounds, if it's visited, or if it is a 1, meaning it's a wall. And these are the functions that do the work to figure out where the next position will be. So when we go up, down, left, or right, what each of these do is they take the maze and the row and column that you're currently at, and they basically simulate the ball rolling up, down, left, or right until it either hits a wall or it makes it to the end of the maze, and then it returns that row. So these will basically return the row or column after the ball rolls in that direction. So once we have those helper functions, it's pretty simple. Here's the initial function we're given. We just return depth first search. We set it to maze, our start row, our start column, the destination row, destination column, and then a Boolean matrix of visited. And then in here, we just run depth first search like we always would. If it's out of bounds, we return false. If the start row is the destination row and the start column is the destination column, we return true. Otherwise, we mark this place as visited, and then we just return depth first search of any of the 4 directions we can go. So, here's going up. Basically, the ball rolls up until it hits a wall or the end of the maze. Ball rolls down until it hits a wall. Ball rolls left until it hits a wall. Ball rolls right until it hits a wall. So that's really all there is to this problem. It's just a depth first search problem with that added little hitch that the ball rolls until it hits a wall. You just have to simulate that, which is what we do with these helper functions right here.